Okay, for the second question, we are again required to find the tight asymptotic bound for another method that is debug binary search. Like when you look at a function body, you will see that yes, it is mainly a binary search process, but there are 2 points that should catch our attention here. That is, if the middle index of array A takes the value of target, that we immediately return. And otherwise, we either update the start or the end index. In any case, like if like after we pass through the if conditional block, and if the function does not return yet, the array would already be halved. And then we enter into a for loop that prints out all of the items in the half array. So this is another part that we should take note of. So at this point, we can see that the best case would just be that the middle index of array A takes the value of target. Now we will immediately return the entire function. So it will just be theta 1, which it will just take its constant runtime to return the entire function. For the worst case, that is, we have to binary search for the entire array. And we know that the binary search entire process will causes at most log n time. However, because of the fact that we are printing out all of the half arrays, the binary search log n process will no longer be our cost model, because that printing out all of the half arrays will take more time than binary search. And if we were to sum up all of the runtime taken to print out all of the half arrays, it will go something like this. It will be like n over 2, n over 4, and all the way up to 4 plus 2 plus 1, which will simplifies to n. So as you can see here, it runs in linear time, which is far larger than the logarithm cost model. In this case, we can give it a tight asymptotic bound for the worst case, that is theta n. Okay, for the last part of question 1, we are considering options of data structures to use as the external chain for our hash table. So before we dive into the analysis, note that there are 2 constraints here. That is, the size of the chain must be proportional to our load factor, which is the number of elements divided by the number of buckets. And secondly, remember at insertion, we need to traverse across the chain to check for duplicates. For linked lists, traversal and insertion, they are cheap and consistent, so linked list is a good choice. For resizing array, recall that resize, we need to copy all elements. So this might be very expensive in terms of runtime, and also arrays allows for random access, but our explanation doesn't actually utilize this property of array, so that might be a waste. For balanced search tree, first of all, it requires more memory cost than linked list. And also, like elements, they have to be comparable. Thirdly, like this is a good point, that is, because the tree is balanced, it will reduce our traversal runtime to big O log n, due to the balanced structure. For hash table, the key is really the hash function. If the hash function is not new, then we will still have collision. However, if it is new, then it might be ideal. You can refer to Coco hashing to learn more about that. Thank you.